So we're going to start lecture number 1. Lecture number 1 is on the website. It's actually called lecture number 1. And it is on fundamentals, introduction to Unix. So this is the part that's going to be extremely boring for some people who already have a background in this. However, it's actually not bad from a trivial, or what do you call it? Not trivial. Trivia is what I meant to say. Trivia point of view, it's actually not bad. Or historical, well, I remember that. Oh yeah, I remember that kind of thing. But the fundamentals of Unix, Unix-like systems, history. I'm not going to go through the entire history, but I will mention a few things. Data management, constructing shells and scripts and stuff like that. Here's your history. For those of you who may not actually, well, you probably have heard of Dennis Ritchie, right?
Yeah.
Yeah, everyone's heard of Dennis Ritchie. He's like the godfather of the C language. He's also the major, well, if you think about it, Unix is C. Unix is a compiler. So it started out, Dennis Ritchie, Ken Thompson, 1972-ish, and we're thinking, wow, you know, you think Unix was available in the 50s? No. It was these geeky guys working at a university, a couple different universities actually, who were inventing the C language. Dennis Ritchie probably gets the most credit because he spent the most time and energy. So he's the godfather of the C language, the inventor. And then from there, they turned it into a complete operating system called a Unix. Why? Because just to have a compiler, what are you going to do with it? You write programs. Imagine not having an operating system, but having a computer program. You're thinking, well, what do I do with it now? Well, you're just going to run it on the computer. And then you're thinking, well, we need to, then this concept of the operating system came out. And the operating system ended up being the middleware. It's the middleware between the hardware and the program that you're running. And if you're going to write middleware, you might as well write it in a language that's compatible with the program that you're trying to run. You're going to run the program in C, so you're going to write the operating system in C. So Unix is written in C. It is all C. It follows C compatible. So there's a reason why undergraduate computer science students always learn C, first language. And they always use Linux. And then on Linux or Unix. And then we have shells that we can use to actually write C code and not even have to compile it. What do we need a compiler for? We need a compiler for non-Unix systems, really. But we have a compiler. We have GCC on Unix systems. It's very popular, G++. If you want to go into the C++ range, object-oriented version of C. But long story short, it was an operating system to make the hardware more functional and more user-friendly. Starts out on big systems, huge systems. Why? Because we didn't have desktop computers back in 1972. We had huge computer systems that were owned by businesses that cost $10,000 to $15,000. No, actually, I should say those systems cost $10,000 to $15,000 right now. Sun boxes, maybe they've dropped a little bit, maybe around $8,000 US or so. Sun systems are expensive. We didn't have cheap little netbooks for $100 on the market. Actually, we barely have them anymore now. The phase of the cheap $150, $200 computer that lasts maybe a week, you get what you pay for. But anyway, long story short, if you read through, and I'm not going to read through all the slide, you can download, this is slide number 1, you can download it and read through all the trivia on here. But the thing I wanted to point out in terms of the history, you can't cover Unix history without mentioning Dennis Ritchie or Ken Thompson, actually. They're pretty much the godfathers. And now we're looking at DEC systems, we're looking at Sun systems, we're looking at HP, that got into the market. Huge systems. Here's their pictures. They look like old Americans. Wow. Actually, they were pretty typically looking back in the, imagine, it's university setting. And it's students and teachers and everybody, grassroots kind of development. But those are early movers and shakers. So these guys are sitting around doing stuff. So 1972, we had B. And then we had the language C that came from B. And then we had, Thompson actually created the pipe. Writing a program to do one thing, do it well, and then write multiple programs to work together. So we'll look at pipes today. We might look at them tomorrow. I don't know if I'm going to get to pipes today. So you write 2 C programs, and you get 2 C programs to work together. So Dennis was more along the lines of getting that C program to work from B, creating C. And then a lot of the other people are going, okay, now you got this, what do we do with it? So then you write a program, and then you redirect the output to another program, or you pipe the output to another program. So the concept of I/O redirection, piping, that's all the stuff that we're going to cover in this course, which is the basis of how do you work with Unix, which is a lot different than a Windows system, actually. So when you think about the concepts. So. Then we have Linux. Unix works on big mainframe computers, still the same, not mainframe, but big, huge business systems, huge Unix systems. And then we got many different variations of Unix. There's not just one. Most people are familiar with Sun. Yeah, Sun makes huge computer systems. So we have Sun Unix. HP also was in the market. I don't know what they're doing nowadays. I don't know. DEC was in the market. I'm not quite sure what they're doing. Sun's pretty popular these days still. Then we got Microsoft, not Unix. Microsoft never wanted to do Unix. Never, ever got into it. Totally different breed. Totally different breed of thinking. Totally different developers. It came later, and it came as a dumbed-down version. Let's make it easier. So it was stripped out, Unix at one point, and then it just turned into Microsoft. It turned into DOS originally. But long story short, the word Microsoft never actually gets spoken in a Unix class because it's like black and white. It's the opposite of what you're talking about in this class. So it doesn't really relate. So anything you know about Microsoft and Windows, just throw it out the window. It's not going to work for you in this class. Microsoft DOS, mainstream operating system. Minix, tried to, not a full port of Linux. And then we had Winix, we had Minix, we had all these different, like a Windows version of Unix. Basically, Linux came around to make a Microsoft version or a PC, desktop PC version of Unix. That's all Linux is. So you're like, well, you know, usually, actually in the online class, people say, can I use Ubuntu for this course? I'm thinking, yeah, it's really Linux, it's not really Unix. We're not using Linux, we're going to use Unix in this class. And they're like, well, what's the difference? This is the same thing. I'm like, nah, not really the same thing. However, for what we're doing at an introductory level, yeah, it is the same thing, but it's not really the same thing. Linux is stripped down. It's desktop version, just the things needed. When you install a Ubuntu system, you don't usually get an Apache server on your computer. If you do, you got too much stuff on your computer, it's going to run too slowly for you. You don't have all of the stuff you have in a Unix system. You usually have a web interface or anything like that. 1991, we got Linux 0.02. We got a very small version of it. With not too many different things with it. I'm not going to read through the whole thing. This guy here, Andrew Tannenbaum, he makes... Here on the bottom of the slide, and my mouse isn't working for some reason. This guy down here, his little quote, he makes a really good programming language concepts book, and he's a university instructor or professor, long term. His books are excellent. He does compiler design, he does programming language concepts. If you see a book by him and you have a choice between buying his book and another book on the same site, get his book. That definitely a lot more knowledgeable. Puts a lot more energy into it. Linus, he doesn't make any books. He makes Linux. He made Linux, which is where the word comes from. So, Linux. So it came after the guy. Actually, the funny thing is a lot of the history of it's just people made up names with whatever it is that they were doing. You know, their names, or like Debian is Debbie and Leonard or something, or it's the name of the whole Debian, Linux, D-E-B-I-A-N, Debian, if I'm saying that right. It's the two names, husband and wife. They just put the first 3 characters of both of their names together, and voila, you got a name for Linux. So where did that come from? We got Red Hat. It's a different black hat, white hat, red hat. Yeah, people are very creative when they come up with these names for this stuff. Sometimes it means it's not technical. Sometimes it's just very low, down-to-earth kind of names, which is actually kind of cool. So here's Richard Stallman. Stallman is actually, he makes really, really, really good books too. So as an author, and they're still producing books. They still have an entire market out there of books. They've all gotten into university textbook writing. But Stallman does. He also works with programming language concepts and operating systems books. And it's a couple of other varieties. He's also the father of the GNU project, so the open source. I'll talk about GNU a little bit later. And then we got Linus. I don't know which one. Oh, this is Richard Stallman on the right, and Linus is on the left. So it doesn't really matter. I'm not going to show you pictures on the final exam and say which one's which. You already have to remember dates or names or anything like that. It's nice to know where all this stuff came from a historical perspective. Not a history class, though. And I'm not going through this in enough detail to really test you on it. But if I said that the Unix came from Windows, you'd probably be wrong with that. Did not. So why is it still being used? 30 years of development, many academic, scientific, and system tools. Open source, system stability, lightweight, easy development. Well, if I were to answer this question, I'd say the internet. That's why it's still been. The internet really made it so it's never going away. The entire internet is Unix. So, which is actually kind of funny because most of the client computers that connect to the Unix systems aren't Unix. They're Windows or they're something else, but they're not Unix based. So, which is actually kind of ironic. Why do people run in fear of Unix? Because of the command line interface. Actually, now we're going to use command line in this class, but if you installed like Ubuntu or something on your computer, you can get Windows. I mean, you can get graphical user interface, which is actually kind of funny. You know, if you look at the history of PC desktop computers and Windows, nobody liked computers back when it was a DOS prompt. And then when we had Windows 3.0 came out, all of a sudden, oh, computer, yeah, let's get one of those things. It's easy to use. And then they started shipping computers with desktops on them, which is actually kind of ironic. So people judge the entire operating system by the GUI, the desktop, which is why you guys are still using Windows. Anyone who uses Windows is judging the entire operating system by the desktop. Because otherwise, if you knew any better, you probably wouldn't be using it. Because here's the thing, you can change the desktop. The desktop is just one component. So a lot of people go for the Unix route, pick a new desktop they like. In fact, there's a desktop that looks just like Windows. There's a couple of them actually that look just like Windows. You can install that on your Linux system. Then you're going to wonder, well, when I bought the computer, it has this Windows on it. Well, that's the problem. See, that's the conspiracy right there. They sell the computer with Windows on it. Every computer out there has Windows on it. Why? Because Windows, easy for people to use. Then you get the Mac. Apple people that sell Macs with a different operating system, not Windows on there. And then people don't buy Macs, and then they don't buy Apple products. Well, they buy Apple products, they just don't buy Macs or computers because they're afraid. They know Windows, but they don't know OS X, or they don't know Mac operating systems. And they go, oh. When in reality, the Mac is more like Unix. So if you're familiar with Unix or Linux, you're a Mac person. Because what ends up happening is you realize, oh, it's just a desktop. Underneath the shell of this thing, we have a Unix system. So if I say that, I made a little terminal prompt here just to demonstrate the point. I have Linux in here. So I have a full running Linux system. I don't even have to tell it into another system. So I can run Linux commands in here. I can run nano. I don't know if I have nano installed. I do have nano installed in here. I can run PHP, I can run Python, I can run Perl, I have an Apache server actually installed in here. I can actually turn this thing, this is actually a web server. All I gotta do is open up a port and I can turn, you can actually go to www and get in my web server. All on my little desktop computer, so it's a little bit more powerful. I don't have to install it, it gets installed into the operating system. Some of it came with the operating system. So,
I have a question.
Yeah?
You said that Mac can be used as a web server, right?
Yeah. You have to install Apache on it.
The same thing is there with Windows also, right?
But you have to install it on top of Windows. It doesn't get installed into it like a server. It's not Apache either. It's a Windows port of Apache.
Okay. I mean, as far as I remember, there is this init pub that we can install in the Windows.
iNet pub?
Yeah, a local host, by which Windows can act as a web server, as far as I remember.
On the computer or off the computer?
On the computer.
Yeah, well, actually, okay, so to illustrate, or to further illustrate your point, yes, there's been ports of most of the Unix. Well, actually, you can install Microsoft Visual Studio, and you can get ASP.NET, and you can run .NET, which gives you web server capabilities. It's not Unix. You can't load Unix onto a Windows machine unless you do the port where it opens up like a virtual machine and it runs it in a virtual environment. If you run it in a virtual machine mode on a Windows system, you're not running it with Windows. You're loading up another engine that's going to run Linux for you or run a server for you, which is how the Visual Studio actually sort of working. It's a virtual machine environment. You load it up, it runs, and then you put your stuff in there and then you turn it off. It's not integrated into the system, and it doesn't run all the time. Otherwise, your system is going to run too slowly. But yeah, modern technology, you can port almost anything over. You can run Python. You can run. I don't know if you can run Perl on a Windows system yet. You have to find a GUI interpreter for it. But they make versions of everything to work on Windows because people have Windows. How are you going to get those people to be able to use these tools? How are you going to get them to program in Python? Here I just type in Python, and I get a Python engine that comes up. So how are you going to do that on Windows? Instead you have a desktop icon, you double click, and it opens up a Python window with a GUI that's loaded on top of your Windows, not integrated into it, that's giving you a Python interpreter for Windows. So most of it has been, actually not most, a good percentage of tools have been ported over. And when I say ported, I mean transported, which is what the real word is. But you port it is terminology just as you moved it over. Like they ported, there's a Windows port for Android. You can run an Android system on top of Windows. You can actually run Android on x86 machines now. There's a port for that instead of on Android hardware. So when you're moving something from one like home operating system or one environment to another, you're transporting it, you're moving it over. There's Windows ports for everything. This is native. This is running Windows. So if I type in uname as, oh, actually I'm in Python right now. If I exit out of Python, well here, let's just do it this way. Let me open up another shell. Get out of here. If I type in uname and I get the name, I have a Darwin kernel here. So uname is a, we'll do that. We'll type in uname over and we'll see what we have. We have a Ubuntu actually is what we're going to log into. And if I were to log into a system, I can go ahead and connect from my computer to another computer. If I did that, I think I actually still have it in here. I can SSH. So right now I'm going SSH root, and I'm going to type in a password here, and I'm going to go, and this is the server I'm going to show you later today, probably after lunch, or maybe even before. And it says Ubuntu. So I went from a Darwin, this is it used to be, it still is BSD, Berkeley Systems Unix is what is underneath a MacBook. A MacBook is Unix. And then on top of Unix we have the desktop. The desktop loads up and gives us our GUI, graphical user interface. Well, you have the same thing. So, and it started back when the Intel processor came and we had the like a major transformation in terms of the port, and it turned into Linux at that point. Which is an x86 port of Unix. So, and then we had Darwin. But the interesting thing is the Darwin kernel is the same kernel that's on the iOS devices. So it's on the same thing on the iPad, on the phone. So you actually have been using Unix without knowing it if you've got an Apple product. But you're using the desktop. You're using an interface, a graphical user interface that's loaded on top of it. So right now what I've done is I've logged into a Ubuntu system. This is what we're going to do. Because I have a MacBook, I already have Telnet, I already have Terminal, I have everything on here already. I don't have to do anything. So you guys with MacBooks are set. You don't even have to Telnet, you can probably do everything here. But we're going to Telnet so I can save everything all together for everybody. On a Windows machine, you'll be installing a program called PuTTY. It's a secure shell port of this a graphical user program that you'll install on your Windows system, and you'll load it up. You'll load up PuTTY, and you'll type in the IP address and your username and your password, and you have a little screen, a little window, and then you type the stuff in the window. Or you can use SSH secured shell, and I'll show you that. So on here I have a Windows desktop. I have parallel system virtual machine emulator like VBox. I'll load up XP because XP is pretty much the base for 7 and 8. And I'll show you PuTTY later on because about half the class is Windows-ish. So, but long story short, what I've got now is a Linux system. So I can change the directory, and I have root access in here, and I can go here and go nano, commands, and I can see there's a file in here. And then I can change the file around or run the file. And I can see that I've got Unix commands that I'm running, and I'm writing scripts. So what we're going to do later today is get you guys to install PuTTY. You don't have to have anything ready to go yet. Install PuTTY. Windows people can take a break, or I don't know, sit and watch. You don't have to. I mean, excuse me. Mac people can break. You don't need. Mac people don't need any software. You already got everything you need. Windows people, we have to get you up to speed. So we'll get you a PuTTY installed. We'll get all the tools ready for you to go. And I'll show you how to log in. And then once we all get logged in, then we spend the rest of the course doing this. What's LS do? And what are some of the things associated with LS in terms of switches and things? And how do we find? I don't think I have man on here. Yeah, I do. Man pages, man LS. And how do I use LS? And how does this work? And it's all about learning and getting more familiar with Unix. So we don't need to install any Ubuntu. Some people have Ubuntu installed. If you have a Ubuntu machine, that's fine. But we still got to do everything on the server so I can grade it all together. So, but this is actually not a bad idea to show you this stuff, actually. So let's see. So that's this line number here, the command line. There we go. Command line and shells. So we're not going to use a GUI. We're not going to have any icons or anything to click on. That would be senseless. So the shell. Talk about shells. Part of the course. User environments. There's different types of shells. I didn't go into each one of the shells yet. Windows Explorer. It might be seen as a shell for Windows. Actually, it's a Microsoft shell. It's Explorer. It's the actually, if you haven't realized it, all you have to do is kill Explorer, and your Windows desktop goes down. It's called Explorer. So it's a shell that you're running. It's SH, shell command. Then we have bash shell. I think we have bash shell, actually. I can find out, though. Echo shell would display it for me. So as an example, if we typed in SH, I'd be in an SH shell. And then I think I'm in bash, actually, automatically. Bash shell. And you're thinking, well, what's a shell? We have a kernel on the bottom. Kernel loads up. Spawns a process. I'm just in a user process right now. I can load stuff into my process. The shell is my command line interface. This out here, this is a shell. This lovely little background image I got on here and all the pictures of the icons and stuff, that's a shell. So I'm now loading another. I just loaded 2 other shells. So I can actually exit out. In the old days, nobody does it anymore. In the old days, you can actually take down the graphic. You can actually exit the desktop shell, get rid of it, and use anything you want to, or load a new one on there if you wanted to. Nobody ever does that. This is pretty good, actually. I sort of like it. The whole utilities are pretty nice for it. So, so you can find out what you're in by looking at, as an example, and we'll go through this in the course too, this concept of command line. I was going to see if I can. Oh, I can. Let's see. Copy and paste. Paste. There we go. Command line environment variables. So if I say print v. Whoops, that's not going to work. Print env. Let's see. I have to remember now. There we go. Print env. So actually, some Unix systems have different variations of different commands. This one uses print env. There's another system I'm familiar with, UC Linux. It does print v. It's a shorter version of it, or env. Long story short, it's print environment. What does that mean? We set environment variables. So Windows people are familiar with, in the old days, autoexec.bat, config.sys, boot up environment variables. XP 7.8, you don't do that anymore. All that stuff came from Unix. Environment variables, setting a path. Actually, if you've done Java programming, you've set a class or a class path or something like that. It's the equivalent. You're setting an environment variable. So we'll be looking at pulling stuff from environment variables. As an example, when I did uname, it pulls it from the environment variable. Uname stands for Unix name. What Unix version am I on? Minus A gives me the abridged version of it. A is for abridged. So it gives me the shortened. It just gives me, if I just did uname, I get everything. I don't want everything. So we have command line switches that we can use to get just the information we want from the command. So we just get the output that we're looking for. So that's basically what we're going to be doing in the course is looking at, and we're going to add stuff to the environment, take stuff out of the environment, use stuff in the environment. And then we can write scripts. And you're like, oh, it's a script. You know, in fact, I can actually, let me exit out of here, right? I can actually write a script as a file and then run the file. So I can take a bunch of, it's like batch files. It's like a bat file that DOS people used to do from the Windows side. Where you create a text file, put a bunch of commands in the text file, change the mode of the file, make it executable. Just type the name of the file and it's equivalent to like running a C program, writing a real program, but it's called a script. Because you're not compiling it into a binary and you're just running it. And then you think about, well, what's the difference between that and Perl? Perl and Python are scripting languages, where you're using a language like C, and you can run C scripts in a C shell. Because you're a C programmer, you know C syntax, so you write your program in C, and then you save it, and then you change the rights to it, make it executable, and then you run it. So now you're thinking about this and going, well, am I a programmer then, or am I a Unix developer, or am I an operating system user, or am I a programmer? And then now you figure out why people are afraid of Unix. Because they go, oh, it's too much learning, it's too complicated. And then now you know why people flock to Windows. Because, oh, you just double-click. Double-click. I don't have to remember about commands, and I don't have to program. But there's no programming involved with double-click. So, it's no surprise why Windows is popular. Echo, or C change, commands we'll learn, we'll go over this. You don't have to copy, I'm not introducing these commands to you, I'm just giving you as a summary. Before we go any further, we had this thing called man. I actually typed it up and showed it to you. So in the old days, there was a manual that went along with Unix. It's on my system, I have man pages. I have a manual on my MacBook, actually. I just type in man space the name of the command. It tells me how to use the command. If I wanted to, I can just use the command line interface all the time if I wanted to. But I like double clicking on stuff too. So most commands are built in, and they're built into the system, and you can get to them by using man. M-A-N stands for manual, short for manual. Minus H for help, or minus. Actually, I did a minus H. I don't think it worked actually on my system. So here's what we're going to find out as we go through. The original assignments that I put together were done on a Ubuntu system. We're logging into a Ubuntu system, so all of those commands should work just fine. On my Velvet kernel over here, it'll be interesting to see what happens. There might be a slight variation. So I'm probably going to just use the Ubuntu kernel, because then I can have apples and apples and not have to worry about the commands not working. But we'll run through when we start assignment number 1 after lunch, and we'll see how the commands actually work, and then we'll go, oh, but it's print V, not print env, or it's this or it's that. So you'll have to learn the command set for whatever system you're using if you're not using the Ubuntu system. So, and most of it's compatible with this system here, so it doesn't really matter. But then the manual has everything in it as well. The only problem is with the manual is you have to know what command you're running. So if I type in man space and I don't know how to do a directory listing, which is what I've been doing, the ls, it's equivalent to a dir for directory. If I don't know it's ls, how am I going to get the man pages? That's the problem with the manual pages. I want to list out the contents of the directory. So instead, and I'm a Windows person, and I've been familiar with dir, but what do I do on a Unix system? How are you going to use the man? You can't use the man pages for that. which is the most ironic thing. So then people started they started Googling everything, right? So now you can actually find the Unix manual pages in a graphical format on the internet. So actually, I haven't bookmarked it, but I'll just show you real quick. It's not too hard to find, actually. You just go to Google and type in Unix manual or manual sections. Or the manual sections will actually take me there. Understanding man pages, Unix tips. No, there's actually a couple of sites that actually have man pages. Yep, here it is, Unix online man pages. A lot of universities put it up here, computer science departments put it up here. This is the same as the, that should look familiar. So if I went and I typed in man space intro, I'm going to get this page that shows up. So what you get on the Unix command system is the text. The funny thing is, you go to the internet, you got this graphical user interface. What am I looking at? The text. It's just the copied into a browser interface instead of a command line interface. Which is actually kind of interesting because this, most people go, oh, you know, the invention of the web browser revolutionized everything. Ever since sliced bread, you know, it's great, right? It's mops and whatever, you know, it does everything. It's just a command line interface with GUI mockup. So then you'll learn HTML and you go, isn't that just text interpreted by the browser? What does this do? It goes and gets manual pages. It goes and gets documents from HTTP protocol used through an open port on an Apache server. So then I realize that, and then I make a public HTML directory on my folder, and I load everything into it. And then I go, oh. And then the light bulb clicks on, and you go, you're just working on a Unix system. You're just putting files into a folder on a Unix system, and there's your website right there. That's how your website's working. This is just a toy. This is just a graphical user interface. We don't even have to use this. We can just go to command line prompt and type in and go to a URL, get a file, download something, show an HTML file, go to Google. In fact, one of our exercises will go to Google and we'll run a search on a command line without using a browser. What do we need a browser for? It's graphical. So all the stuff you do graphically can all be done manually. Who's going to do it manually? I'm going to pull up a browser. I'm going to pull up Firefox. I'm going to do everything with Firefox because it's easier. So anyway, that's the manual pages. Conventions for this lecture. We have, is this the attendance person? No, this is another student. Okay, so we have, during the lecture, the commands will be in bold. This is consistent among all of the other lectures that we'll have for this course. All the commands will be in bold, and all the arguments will be in italics. So we'll see a command in bold. Just in case you miss something, you come in late after lunch or something, and you're like, huh, what is this she's running? All the commands are in bold. Doesn't mean they're in bold on the computer system, they're just bold in the lecture so you can tell the difference. And then the command switches, the arguments are in italics. So, and the convention in the lecture, which is actually kind of odd, is that, you know, you see this, like, my mouse isn't working, but you see there's a minus sign in front of command. So some of the bullets and things in this lecture kind of throw off your perception. You don't type a minus sign in. So, and then that sometimes the prompts are dollar signs, sometimes they're minus signs, sometimes they're nothing. So, long story short, you kind of have to sort of just look at whatever's in bold and go, that's the command. Here's some examples. CP. And then we have CP minus R for recursive, for copying stuff. These are some command syntax that you'll see in the lecture. This follows the same syntax or similar syntax as some of the original man pages do. So, and the interesting thing is once you start looking at the syntax for a while, then it becomes clear because it's all consistent. And then you'll go, oh, it's just syntax. So. Whose path is it anyway? Interesting thing about Unix systems is that there are multiple user systems, multi-user systems. If you're from a PC environment, you think you're on an island of your own. Every time you use your computer, you think you're the only one using it, because that's how it is normally. Or if you're not using it, somebody else is logged in and they're using it, and you have this user account kind of concept. But it's all the same system, all the same file structure, all the same directory structure, all stored on the same disk. Unix, not the case. Unix, you have You go and you say, oh, we're going to put Unix in the company. You buy 3 systems. Well, they're $10,000 each. I don't think you're going to buy too many of them. You're not going to buy a $10,000 system or a $12,000 system. I shouldn't say that. I think they're more like $8,000 now, but let's just hypothetically assume they're 10 grand each. You're not going to buy one for 200 employees. You'd be broke. In fact, you don't need one for 200 employees. You need like 3 of them. Actually, you could probably get away with 1 for 200 employees. But let's say you're going to be generous because you're going to grow. You're just going to buy 2 or 3 of these guys. And you stick them in there and you plug them in and you hook them up to the internet. That's all the computing resources you need for 200 employees. What do? You buy Windows. You don't buy Windows. You don't buy Windows. You buy Windows. You buy 200 computers. So you put the 3 out there. You install them in the computer system. Or, IT people put them out there in the server room. Actually, believe it or not, you know where these guys usually sit? At the receptionists. One will go into the developer's room. The other one will be sitting right out, which is kind of ironic. They don't do it anymore because of security reasons. People, you knew that. So you come in and you steal the receptionist's computer. You're like, why are we stealing her computer? Because it's the server. Why? Because she's not doing very much on it. She's just sitting there. She can use the screen and the little box that's underneath, because that's where you got the space. Or big box, actually. But it sits underneath the counter, or it gets locked up underneath the counter nowadays. And she's sitting there with a terminal window, a monitor that's connected right to it. She's not going to do anything to it. And she doesn't have any privileges. This is why she gets it, because she's got a very limited account. Does not have root access, does not have anything. And then the other one is in the back room, and the developers are using it. So why? Because they need to configure everything, and they're on it. So everybody else in the company is still connected, but they're connected to one or the other, or both. Depends on what's going on. It's distributed computing. So they have terminal windows and keyboards. They have computer systems. They have a window, a screen that looks like this, but there's no computer in it. It's just a window. I mean, it's just a monitor. I keep calling it a window. A monitor and a keyboard. They used to call them terminals. So you have the terminals that are connected, and then you have terminal connections. So I log in from, just pretend that's a window, it's a monitor. I log in with my monitor, my terminal, and I access the system. Is there someone standing at the door? Oh. And I'm almost feeling like I have a computer here, and I'm an island of my own. I have my own interface, and I even have Windows that comes up, and I have a desktop, Sun Windows that comes up, and I have my own shell into the system. And then all the other employees, all the other 200 employees, they do the same thing. It's really just 2 computers, or 2 physical boxes. They don't really call them computers. They're Unix boxes. You have 200 connections into it. And you're all doing your work, and you all have your own perception as if it's your own directory structure, and it's your own files, and it's your own system. But it's centrally located, so you can back it up, restore it, and you can protect it, and you can monitor it, and you have all the capabilities from an IT perspective to have a better control over it. You're a Windows person, you take your notebook home for the weekend. Do I really know what you're doing on it? As an IT person in the company? No. Do I have any control over what you're doing with it? No. They've been spending years trying to figure out how to monitor and control, and some people put like monitoring software and company software on the company computer, because people will take them with them and take it home. So then the natural suspicion is, well, what do we do then? We're stuck at the office. We don't work at the office anymore. Well, then no, you go home. You guys are not at the Amazon site for the server that we're going to log into. But we're going to be using it as if you have access. You have a computer account now. You're going to have access to a Unix server, and we're going to log into the Unix server. We're going to use it as if it's our computer. What are we going to do? This is a terminal. So your host system, your client, we're going to load a terminal program. You're going to use the program PuTTY. You're going to log into the server, and you're just going to pretend like go back to the 1970s, and you're using a terminal, which is all you had. So what do you need all the rest of this stuff for? You don't. That's why they call these fat clients, and the other ones were thin clients. A client logs into a server, You don't have to know anything about networking to understand client-server networking. We have 2 servers, or one. Let's just say we have 1 server. We have 1 server, and we log into it. All thousands of clients log into it. So why do you need anything here? All the processing is on the server. You just need a little window. So you could very well just have a keyboard, a mouse, and a screen, a monitor. No processor. You need an Ethernet card. You need a network card. So that's what you get with the tablets. And that's what you get with cloud computing. Cloud computing, nothing new. Cloud computing is a Unix server. In fact, you're logging into a cloud account, by the way. But you're not going to know it. They call it Amazon Cloud Services. So it's an Amazon server. In fact, it's the same server system we run the EMS on. But you're not going to see the EMS. You're going to see directory mapping for you, and you're not going to have full access to the server. You only get access to what you're mapped to. Which kind of goes back to here. Treats the directory structure as a hierarchy of individual paths. You can take both of these hypothetical computers and make them all seem like they're one computer by the paths, by the directory structure. Because you have this directory structure that's separated from the hardware that it's installed on. It gets loaded up, creates an image that spans multiple computer systems, or and you have multiple hierarchies and multiple abstractions of that. You have a login account that does what's called mapping. You map the user to folders, to directory, to structure. You put them into the structure, and then you have access to what you're given access to. And you could be sharing files, you could not be sharing files. And then there's a whole structure to it from a Unix perspective, starting out. And here we have this home directory. You know, home is pretty popular, and we have home actually on the system we're going to log into. And from home, I get student 1, student 2, student 3, student 4, and I can actually see all of your accounts. I have access to all of your accounts. You only have access to your accounts. I mean, actually, you can see the other accounts. You just can't open the files. It's restricted. But you'll be able to sort of get a better impression in terms of what's going on with the directory structure. But know that that's not everything. That's only what you're seeing. Why? Because there's millions of other customers who are also logging into this Amazon server. And the EMS is running on this Amazon server. And then you're wondering, well, is it really running on this Amazon server? Probably not. Amazon's got thousands of servers. Just like Google's got thousands of servers. You go to google.com or whatever. You think you're logging into the same server every time you're doing that? No. You're being routed by, well, it's called load balancing. But you're going to be balanced to a server that doesn't have as much traffic at the time and day. It's going to be a completely different location in the world. Probably going to be, well, most likely it's going to be on the West Coast, but we don't know. Because for transfer speed, the closer you are physically to the server, generally the faster the speed is, better quality of service. They're not going to take people from California and connect you to the East Coast and New York servers. We're going to hop our way to the East Coast. You know you're on an East Coast server when you're not quite as responsive. Well, and then you just shut your browser, open it back up again or whatever, or just better yet, just refresh your connection. Just hit the refresh button and you'll probably get closer server. So if you're ever running slow, just refresh on anything because you'll end up getting connected to a closer server. Why? Because we have servers. Not too many though. Maybe a couple hundred servers. I don't know exactly how many Google's got, but they're not going to tell you anywhere. And they're not going to tell you where they're located either because they're going to be out in the middle of nowhere. Hopefully someplace where it doesn't rain and then we don't lose the power because you want the systems to be up 24 hours a day. Which is why the Midwest is actually pretty popular for server farms. All right, you remember the crops in the old days? You know, well, actually, you guys don't. I'm talking as if I'm talking to American, like who grew up in this area. In the old days, we used to have farms in Northern California. We still have them. Actually, some people say you could take Northern California and break it out into two or three different states. Because in the old days, we all were farming. And then Southern California turned into the industrial, you know, people took the farms away and built houses, neighborhoods and stuff. Actually, if you go up to Napa, you'll see what I'm talking about. Take a trip to Napa. Or take a trip to San Luis Obispo. That way or that way. We're kind of like in a bubble here of we're very similar to Southern, but not as bad as Southern California. We're industrial over here, but we used to have farms, and the farms grew crops, you know, for potatoes and corn and all this other stuff. Now we have server farms. So we took away the vegetables, and we have computer equipment. So California's full of server farms, and so is most part of the Midwest, because we have better weather here. The chances of our electricity going down on our farm is very slim. In fact, right now, they're even talking about a drought. They're on the news last night, they were talking about, because we're not getting any rain. In fact, it's like 70 degrees outside. This is January, people. We're supposed to have rain, and we're supposed to have, now, this is actually good. It's good for technology, really good quality of service right now. Long story short, if we don't get enough rain, we're going to have exact opposite problems. But our server farms are thriving right now. They're really good, because everything's getting routed over here, because this is, you know, no problems. You get rain, storm, thunders. You lose your power, you lose your servers. So then you got generators. Actually, now they have generator technology that will keep everything up for like 2 or 3 days. And usually power is restored within 1 day at most. But anyway, slightly different tangent here, but it's interesting how some geographical areas, if you can decide where you're going to put your servers, then you can maximize the other conditions associated with it and really spread out the service. So companies, big companies who use Unix servers for, let's say, for example, Target as an example, they'll have centralized servers. We have one in Colorado, you know, and all of the cache, actually Fry's does the same thing. You go in one store, you buy something, and you go around the block or to another store and you return it. They look you up, and it gets reconciled with the server. All the stores are connected. They're connected by the servers. All of the software that's running is running from the same server. So it just gets reconciled. In fact, they do it real time. They used to do it at night. So you waited a day, and then it was, or they had to call, if they ever say, oh, you know what, I have to connect to a different server, and oh, it's going to take a little bit longer. What store did you buy this at? You know, then they ask you, well, where did you buy it? Or they look at the receipt. They go, oh, Campbell. Okay. And then they log in directly into the other server because it's not reconciled yet. Real-time reconciliation is really hard to do. When I mean reconciliation, it's taking all the records, all the transactions that are all going to a central location and then putting it all together and doing all the accounting on it. That's reconciling all of the different debits and credits from throughout the day. Usually happens at midnight because otherwise it makes the systems run too slow. Banks do the same. Banks are still doing that. So some banks are doing it faster though. We still don't have real-time syncing yet, real-time reconciliation. But long story short, all the targets, maybe 4 servers. 4 of these $10,000 servers. Actually, I can imagine having a little bit more, but they don't really need it, actually. Because then you have local terminals. And the terminals are pretty fat. What I mean by fat is they have hard drives on them and disk drives and stuff. Thin terminals don't have anything. They can't do anything there. So as a consumer market, we're going thin again. We got fat for a while when we got away from Unix. Now we're all going back to Unix. Cloud services, all Unix. So now people are starting to use Unix and they don't even know it yet. When you can put together a Google Drive, you're on a Unix system. You have your Mac Drive, Unix system. Windows Share, whatever they call it now, Unix. So now you log in and you have this syncing and you have this drive. Where's the drive? Not here. This could be nothing. No, you don't have to have anything. You just go to the drive. So why can't you do that from your tablet? Tablet's a thin client. You know, some of them has a little bit of memory on it, but not much. Store everything online. Put everything on Unix. And then now we've gone full circle. We started with Unix. Then we got fat. Now we're on a diet. We're going back to Unix, which is actually kind of interesting. So if you follow the trends. So I was talking about directories and paths and stuff, and the question is, whose path is it anyway? Nobody's. You're all sharing the same storage space. You all have a different view and a different abstraction of it. When you log into it, it looks like it's yours, but it's not. You only see part of what you see. If I log in to a system, I have maybe a dev folder, maybe a home, maybe a user folder, and then I'm just going to see bhacker. I purposely made it so you can probably see all of the student accounts. You can't touch or change anything in them, but you can see it, which is interesting actually to look at. You go, oh, I'm not on an island of my own. My system is using everybody else's system. So usually the light bulb doesn't really click on until you start doing stuff with it, and then you realize, wow, this is pretty powerful. But what we're doing is just what you've been doing all along with the internet. You've just been using a web browser for it, for some of the document exchange stuff. But anyway, directories, PWD will tell you where you're at. LS will show you the working directory. Finding your home, changing directories, changing, and we'll go through all these commands when we start looking at the first assignment. But changing directories, changing the home, and then learning, what is this tilde thing in front of bhacker? My mouse isn't working, but what does that mean? Or, this environment variable for a home. And it's just different navigational techniques, different ways of navigating the system. Here's more file commands to look at. You don't have to worry about learning these. We're going to go through these today. But changing a directory, listing out stuff, moving stuff around, copying stuff, removing something recursively, stuff like that. In Windows, most people in the old days were familiar with some of these commands because they used DOS commands. They opened up a DOS window and they typed in DOS commands. There are people today that have never heard of DOS. I noticed actually some undergraduate students, you say DOS. There's no DOS anymore. Oh no. Oh no. I think they took away DOS. Didn't we still have DOS in Windows 8? Don't we still have DOS? It's a shell now. Yeah. It used to be the underlying operating system, and then they loaded Windows on top of DOS. Now they put DOS inside of Windows. They switched it around, which is actually kind of interesting. Because now Windows is more Unix-like than it ever used to be. So I'm waiting for it to become real Unix. I'm waiting for DOS to go away completely and have Unix underneath it, which is probably going to happen soon if it hasn't happened already with 8. I don't know. I'm not familiar with it. I haven't looked at completely all the internals of 8, but it's suspiciously closer to Unix than it has ever been as an operating system. So we'll look at relative versus absolute paths. Where are you relative to the rest of the system? And what is my full path? And so this is part of the stuff we'll be looking at in the course. This is an introduction lecture, so I'm just giving you an overview of what we have to look forward to today, actually. We'll look at this today. Where are you navigating and changing directories, and we'll just run through a bunch of exercises. How much disk space do I have? So we bought these two huge server systems, and they have 300 gigabytes each, perhaps. You think you have 300 gigabytes? No. You have whatever the system administrator gave you. So you can allocate resources per user. Share it. So you're all on the same disk, but you all have different abstractions of it, and you all have different amounts available to you. Just look at Gmail. Gmail is a Unix application. Look at how much disk space they give you, and then they can actually raise your quota. They can raise your disk space for you if you want. And you used to be able to buy a premium account and get more disk space. I don't know. Some of the accounts you have smaller amounts. It's relative. It doesn't really matter how big the disk is. Windows people, they buy a disk, they get the whole disk. Unix people, you buy an account, you just get whatever it is they assigned you. That's your quota. So how much disk space do you have? Quota will give you that. Commands to see how much you've got. How much are you taking up? DU, DF will tell you. You type the command in and you can figure it out. Hints on space. Almost all commands deal with file space. So we'll display it in kilobytes or bytes. Nobody finds that really useful. So you change the command to have it look, more readable, more human readable. So as an example, ls with a minus LH will show you what I'm talking about is this. So if I type in ls, well actually that's not even going to do it. So ls minus HL, I can see more information. In fact, I can see, am I still on the Unix server? I'm still connected to Unix server. No, I'm not. This is my local drive. Okay. I think I disconnected. At least I hope I did. It doesn't really matter. Problem is, it's not going to connect. I'm always going to be connected until I disconnect. And then if I don't disconnect, I don't type exit or log out, my connection is still open. Not so safe, really, when you think about it. But I can get the rights, and we'll go through the rights on a directory and a file. That's part of what we'll look at in this class. The owner of the file, how much disk space it's taking up, who owns it, and what's the name of it, how many bytes and kilobytes, or, and all of the useful information. Actually, I'm going to exit out now. Now I'm kind of, no, that was my MacBook. Okay. I'm like, I don't want to be connected anymore. So, am I still connected? No. Okay, good. I'm out of there. But some of the other things here, as an example, DU. It's like, wow, that's not very useful. I did that on purpose so you can kind of see. It's still running. Oh, no, it's still running. It's going to run because I have a 250 gigabyte drive here. It's going to tell me everything that's on it. How long is that going to? That's going to take a long time. So it didn't take that long, actually. I don't have that much stuff on here. And I have a fast processor. But long story short, I can make a switch on that, make it so that it tells me only this directory, or how much disk space have I used in the last, either by folder or by partition or whatever I have, instead of just everything. And then DF, the file system. So here it is here. And you're looking at this going, well, what do you mean by folder, drive? In Windows, we partition and we have C drive, D drive, E drive, F drive. In Unix, you don't have that. You have mapping. You can still partition, but it's common to see mapping. So mapping to different drives for different purposes, for different subsections. So we map out the system. We create a home map. We map everybody's starting user to a home directory. And then that's your base directory. You're starting from there. You can't navigate back to root, and you can't get out of there. So you're stuck at an entry point into the file system, and you can go for a certain length that you're given access to for a certain mapping. And we put file restrictions and directory restrictions on there, so you don't even see it. So part of a system administrator is to come up with the configuration of the profile for all of these users and how we're going to map them. Because you may not necessarily see everything that's on there. You're not going to see everything. You're not going to have access to everything in the system because you're going to have limited restrictions for your user. So. All right, let me finish this up so we can go on break. But representing the space can be represented in certain ways. And this is what I was talking a little bit ahead about in terms of permissions. Higher level of permissions, higher level on, how you're going to make a file act a certain way or a directory act a certain way. In Windows, you compile something and you have an exe file, and all of a sudden that's executable, or a .com file. In Unix, I can generally tell the students who don't have any Unix background when they compile something with GCC and they put a .exe extension on the end of it. And I go, oh, you're a Windows user. Because there's no such thing as a file extension like that on Unix. On Unix, you just call it, actually by default it's a.out. But you just call it whatever you want to call it, and you set the permissions on the file to make it executable. That's what makes it executable. It's a slightly different concept than it is on a Windows system. So generally, you can tell the difference between the two kinds of students by how they're going to name their files, essentially. So the concept of permissions overrides file extensions in the Windows world, and we'll get through that later in the course. Actually, probably we'll get to that later today or tomorrow. And then arranging groups of permissions for different types. So we have the owners, we have the group, we have everybody. So we have different levels of access that we'll look at. I'm not going to look at it now, but we have read, write, and execute that we can put on something. 3 levels for 3 different groups. And then there's the other. You can set other permissions and customize that. And we're going to see this in the first assignment, the change mod command, to change to change permissions on a file or a directory. We have a change password that we'll use immediately to change your password on your account. And then change owner. I could actually do that. So I can change the owner for any of your files to somebody else's files if I wanted to. But you can't do it, but you can only do it on your own files. So when you go look at the directory structure, you go, oh, I can see everybody else's files, but you can't open it because the owner is restricted. So you're wondering, well, how does the owner work? You know, and you're thinking, if you're from a Windows environment, you don't know that people own things. You think it's all owned by everybody who uses the computer. So then you'll be introduced in this class in terms of the concept of file ownership, directory ownership, and then everything on the system is considered a file. So, who am I, password, stuff like that. These are the stuff that we're going to go through today when we start hitting in the lab part soon. What everybody else is up to. Top, show the details, refresh the description of the running processes that are going on. Uptime, how long has the system been up? Who's connected, stuff like that. How long have they been connected? So, working with programs, running PS. So some of you have taken a systems programming course. There's a little bit of overlap with this stuff because in order to see what jobs or processes are running, you got to run a PS command to kill a process, kill command. So we're going to run through these commands in a few more details. So I'm going to actually kind of skip through this a little bit. I'm going to skip through all the way. Let me talk a little bit about Nano. Nano is small. Pico is the other one. I like Nano, so I'll show you Nano. There's about, I don't know, half a dozen different text editors you can select from. What you use in this class is completely up to you. If you're a Unix person, you like VI, use VI. I don't care. I don't know anyone personally. Actually, I do know some students who like VI. You like VI, use VI. Like Nano, use Nano. You don't know what I'm talking about yet? You'll probably end up liking Nano. Because that's what I'm going to demonstrate with. We have input and output. So some of you have taken a C course before. You know about STDIO, standard input, standard I/O. Yeah. This is what you've been doing. You've been reading and writing the standard input and output, and we also have standard error. Some of you have actually done exception handling in C to work with standard error. Some of you guys have redirected output to standard input, standard output, stuff like that. So you'll see what I'm talking about when we start running some of these commands, but it's the I/O system. So every person who telnets in, who creates a remote connection, has their own version of input-output error. So you'll be able to track it per user, so which is actually kind of interesting. So we'll see that as we go through some of the exercises. File redirection using the arrows on the command line. So you could say my program and then send it to my file. And then you're just redirecting the output to a file instead of the I/O. Because when you think about it, the I/O is an abstraction. Your instance of the I/O that you're getting from your telnet connection, nobody else can see that, only you can see that. It goes away when you log out, actually. But you create a separate instance of the I/O. Why? Because 200 people are using that one computer. Well, they're not all sharing the same I/O. So if you create an elaborate I/O system, then you have the monitor I/O. So you have the I/O from the user account that's being redirected to the terminal window of the monitor of the user. So they're all sharing their own separate I/O. Windows people don't normally think about that because they're all sharing the same I/O. Because it's one I/O system that's for the entire computer. They turn the computer on, and they don't think about other people using the same computer simultaneously with them. They think they're the only ones using it, and they are usually the only one using the computer. In the Unix environment, many people are using the same thing. So somebody might be running a backup job, somebody might be running an accounting program, a word processing program or something, and they're all doing it simultaneously. And it's distributed computing as well. Some files are on this server, some files are on this server, some files are on that server. You need more computing power, you just buy another server and you hook it up. You add it to the mix, and then you spread everything out over 3 servers now instead of 2. So it's easy, actually. You just expand, you need more room, you just add another server, add another server. So it allows your company to grow quite quickly. So it's like adding PCs, I guess. It's cheaper in the long run. Which is actually kind of ironic, because the reason why PCs ended up in the business world is because people thought it was cheaper. It sort of was in the beginning, because servers were really expensive. And then you bought too many servers. I'm thinking like 10 or 15,000 is what I'm thinking. About 5-6 years ago, in the beginning, they were like $30,000 for a Sun server. Companies aren't going to buy a $30,000 server. when they can buy a $500 notebook computer. So they gave PCs to people because they were cheap. Now it's actually more cost effective to buy the server again. So servers are making a comeback and getting server space, not even having to buy it, just leasing the server space. Why own it? Just go to Amazon and get cloud space. It's the easiest thing to do. That's now more popular. So are you still going to buy computers for all these people? You don't need to anymore. You could buy dumb terminals, or you could buy terminals now. So now the concept of the Chromebook was actually kind of interesting. The Chromebook is a dumb terminal. It's a dumb terminal. You're not connected to the internet. You don't have connectivity. So now there's a couple more companies that are making more elaborate desktop Chrome-like systems. Nothing new. It's a thin client. It's a thin client from the past. It's a Unix client. So now you buy the Amazon space. You give your employees the dumb terminals. They log in. This doesn't do anything. If it's not connected to the system, that Chromebooks don't do anything. They're not going to do anything at all. They're useless. So, which is why they're so cheap. You're not buying anything, which is actually the most ironic thing, because people think they're buying something. It's like, no, you're buying a dumb terminal. You should be paying like $100 for the dumb terminal. Don't buy that much. Don't spend that much money on a Chromebook. But if you are connected, it's just like a desktop computer. It's just thin. It's lightweight. It's thin. And when I say thin, I mean it does nothing on it. There's no hard drive. There's a small little hard drive. Sometimes you could put the USB drives or the SD cards in there. But it's not going to have a big hard drive on there. It's not even going to have a big processor. It's not going to have anything. But what do you need? So a lot of companies are actually thinking about, and some of them in California have actually done this, gone the Chromebook route. You get a nice keyboard, you get a nice monitor, and a nice Ethernet card, and there you go. What do you need to give computers for companies? Why do you need a computer anymore? You don't. So
there can be some security issues with that, right?
Yes, there's cloud security issues with that. You're right, which is why a lot of people are not jumping on the bandwagon yet, because you can't control what you put out there. So then you go back to, well, are we going to buy the servers then? You spend a lot of money to own the servers, and you're going to maintain the servers, but you can put security on them. You want to take the easy way out. You buy your employees dumb terminals, you rent Amazon space, and you put everything on Amazon. And then you take the risk of everybody seeing your proprietary data, because the cloud security is weak right now, and this is your company. So what are you going to do? You know, you're stuck between a rock and a hard place. So a lot of people are just staying status quo. We haven't seen a big move yet. But the idea of that Chromebook in the beginning was it was the consumer's equivalence to what's happening or what should be happening at companies, because we've gone full circle now. The computer is is an appliance, like a toaster. It does a job. So you buy a cheap toaster or you buy an expensive toaster. It doesn't really matter. If you're a company, what are you going to do? You're going to try and take the cheap route. Consumers can own expensive toasters, but why does a company need to give you an expensive toaster if it doesn't have to? So a lot of jobs actually that don't require security stuff, data entry stuff, receptionist computers, which is why the server always ends up at the receptionist desk, because that's all they use. And then you block the internet access on it, and then you don't have them surfing the internet instead of working. You can have more control over the dumb terminal than you can over the thick client. So, because the thick client, you can put stuff on there. Dumb terminal, you can't do anything with it. Thin client, you can't do anything. When I say dumb terminal, I mean thin client. So I'm mixing the terminology. It's thick and thin, or it's dumb. Dumb is dumb. Dumb is thin, which means it doesn't think. Do you really want your computers to think? Depends on how productive you want your employees to be. If you have a programmer, actually, if you have a programmer and you really want to capture all of their work, you don't want them on an intelligent system. You want them connected to the server, and you want them doing everything on that server. Because you're going to get everything if it's on the server. If it's on somebody's notebook computer, you don't get it. And then the age-old question, well, what if they leave the company and they go home for the weekend? They can't work. Yes, they can. Then you have all the RSA remote secure remote connections. So then you give them software and tokens and cards and security devices so that they can connect from any computer that they want to. But they go through the secure channel. And then they connect to the server, and then is almost as if they're sitting right there in the building. You have the best of both worlds, and it's all together. What you don't want is them copying stuff over. That's ridiculous. If that goes on in 99.9% of all companies, you do something on your computer and then you copy it to a network drive. You got it stored here, you got it stored there. Talk about security issues. Yeah, as soon as you have an employee taking it home with you, you got problems. Actually, the Veterans Administration, there was a case with the Veterans Administration. This is the U.S. government. You guys hear the stolen laptop case about 5-6 years ago? It's the most pathetic case you could possibly think of. Okay, a slight tangent because this is actually related to what I'm talking about today in this introduction. The Veterans Administration was processing health. This is before the Obamacare thing came into place. The health benefits for veterans. So they were doing some analysis on the conditions of all these veterans and what their problems were and how much they were spending and all the out-of-pocket expenses. So they had a whole database of veterans from the Vietnam War and prior. Most of them are still alive and willing, you know, kicking. They're still part of the VA hospital and yada yada. They divide the work out amongst about 5 different people. One person decides they're going to take some work home for the weekend, loads a good portion of the database onto their computer, takes it home for the weekend, stops by at the grocery store, leaves the computer in the car, computer gets stolen. So the person comes back and says, yeah, I lost the computer. So they fired the person. They said, hey, fired. Then we have a class action lawsuit among all the veterans because of breach of privacy. You know, it is pretty much privacy, invasion of privacy. So a class action lawsuit against the Veterans Administration for all the veterans because they don't know who's on the notebook and who's not on the notebook because we don't know what copied. Finally, they figured out what was copied. They got that from the server. But the whole moral of the story is don't give your employees laptops and don't let them take the laptop home. Because the veterans each collected $15,000 to $16,000 or so. I can't remember what it was, but it was only in the thousands. They had a class settlement. Each one of them collected a good portion of, you know, a couple grand, enough to buy a car, you know, $15,000, $16,000. The guy sued for wrongful termination because there was nothing in his contract that said he couldn't take his work home, and he was actually trying to do good for the company by getting some stuff done over the weekend. So he got like 2 or 3, it took a couple years to settle this case. So he got a full salary for 2 years plus compensation benefits. His boss got fired too. Same kind of similar thing happened with that. Lots of money was spent. They found the notebook about a year after everything was settled. It was in a used, recycled computer store. The thing had never been turned on. Then they're looking at this going, why are you giving stuff, why are you letting your employees bring in computers? And why are you letting them store stuff on their computer? And then you're letting them take the computer home? And this is the government that's doing this. So then they went, okay, now we have fair use policies, we have acceptable use policies, and computer use policies. For approximately the year 2000-ish, all this stuff came into effect. And then the private sector is slowly taking it over. So you go into a company, they're trying to get you on a, this is a Unix server class, so we're talking about Unix. They're trying to get you on a Unix server for the main reason why they want to make you dumb. That's why I use the word dumb. They want to make your terminal dumb. If you're smart, you're a risk. If they make you dumb, even if they give you a fat client, they can still make it dumb by making you log on to the server. So they install software on your smart computer to make you dumb, so that you have to log into the server. Nothing gets copied onto your computer. Everything is run from the server, centralized location, generally an in-house server, and there's authentication. Sometimes they use like multiple levels of passwords and randomly generated keys and two-phase password authentication and all these very secure ways to getting you to log onto that computer. It's a hassle for the most part. but you still have access to it even if you take the computer home. Most of the time you still have access to it. I shouldn't say in all cases. And then they have you sign policies that says you will not copy anything from a computer server to your local system. So if you're going to do all that, what do you need a smart computer for? You can use a Chromebook. So then now companies are getting smart nowadays. They're going, why are we giving them really nice computer systems? They don't need any of that stuff. All they need is a a monitor and a keyboard and a mouse. So now we're getting terminals back, which is fabulous because then you can use the terminal and you don't have to worry about any risk. And the company doesn't have to pay out a lot of money when someone takes something home that they shouldn't take home. And now if you go get a job at a local company and they have fair use policy, read that stuff. Because you can be in violation if you copied something to your local system. You can be in violation if you go to a website while connected, an unauthorized website while connected to the server. Whatever you're doing on the server is property of the company, yada yada, you're representing the company, yada yada. There's rules and regulations now, and they can fire you, and there's no wrongful termination suit. So, it covers them for wrongful termination, it covers them for acceptable use of the computer resources. Also takes your privacy away at the same time. Because you're booking a flight to go to see your ITU class, and you're at the company computer, and you're on, and you're connected to their VPN, and you're there, and you decide to book your flight. Technically, the company owns your flight. It's their flight, not your flight, according to all of the data protection laws. Everything you're doing is company owns. So don't use computers at work to do personal stuff, long story short. Because if you haven't realized it yet, you've lost all control and rights of everything you're doing on the computer these days. So how's that computer not a toaster now? It's equivalent to a toaster, seriously. It's almost like a stapler in the office. You take the stapler home, they can fire you for stealing the stapler. Well, the computer is just nothing more like the stapler. Ownership of the company. They own it. They use it. Whatever you do on it is theirs. So anyway, that's a little bit of a tangent. Let me go back to the lecture. We're almost ready for our first break. But commands, redirecting. So after we get done, we start installing, we start getting the accounts working. We're going to run through this stuff. So I'm going to revisit this lecture to show you all this stuff live. So I'm going to kind of get through this. Compressing files. We have utilities on Unix to do stuff that Windows, it's been ported, pkzip's been ported, and actually it's part of Windows now. But we have other compression utilities as well, tar, rar, tons of other stuff. SSH, this is what we're going to do to connect to another machine. So we're going to take your computer, we're going to take everybody's computer in here, turn it into a dumb terminal, thin client. We're going to experience thin clients today, and we're going to SSH, I just showed you actually this live in the beginning of this lecture. SSH into another computer and use the other computer. We're not even going to be using it. So you could actually seriously just have a monitor and a keyboard and a mouse today. And that's all you need. Which is why you can connect on a Mac, on Windows, a tablet. You got a tablet, you could do it on a tablet actually. You don't need a computer for this course. You're not going to be using it. This is going to be nothing more than a monitor and a keyboard is what you need. So. But if I told you to bring in a monitor, keyboard, and an Ethernet card, half of you probably wouldn't have understood me. Actually, if you have a Chromebook, you can use that for this class. Works on a Chromebook. So, all right, copying files, removing, looking at your environment, basic shell script, variables, conditionals. This lecture is pretty long, but we're done with it. So it's time for our first break. So I'm going to stop the video.